Number 29, Rowan, is training to run in a race. He runs 15 miles in the first week, and each week following, he runs 3% more than the week before. Using a geometric series formula, find the total number of miles Rowan runs over the first 10 weeks of training, round nearest 1,000. So this just flat out says, hey, use the geometric series formula. But we got to remember, this 3%, if you just multiply something by 0.03, it's going to make it go down because this is a decimal less than 1. When we did these, we talked about how what they actually get multiplied by is kind of like the 1 plus the rate here, the percent, like in the exponential formula. So R, and this R is different than the R in that A0 formula. R, this is the ratio for the geometric series. R here is 1.03. So then all we got to do is just plug these numbers in. The formula, the sum of the first n, however many, A1, and I'm just copying this right off the formula sheet, minus A1 times R to the n, all over 1 minus R. And then 15 miles minus 15 miles times 1.03. We want the first 10 weeks, so that's n, all over 1 minus 1.03. And, oh, there's my calculator. I'll just type the top in. Divided by, I'm going to put parentheses around the bottom. And remember, if you just know that that would be negative 0.03, that's fine. To the nearest thousandth, tenth, hundredth, thousandth, 958. The average monthly high temperature in Buffalo in degrees Fahrenheit. Now be careful. Yeah, this says degrees, but it isn't degrees in a circle. It's not angle degrees. It's temperature. So forget about that. Let's just think Fahrenheit. It can be modeled by the function b of t, 25.29 sine 0.4895t minus 1.9752 plus 55.2877, where t is the month number, state, to the nearest tenth. The average monthly rate of change of temperature between August is month 8, November is 11. Now, the rate of change formula. It's the change in output over the change in input. Y2 minus Y1 over X2 minus X1. Again, these are the inputs. So I can fill the bottom in. To get the outputs of this formula, I got to use the formula. So now, like I said, this is not degrees of the circle. That's not what we're doing here. So we want to be in radians. Like I had mentioned, pretty much everything in math from here on out, if it doesn't say like degrees in a circle, this is here just to be difficult, then it's going to be radians. So we got 25.29 sine, I'll put the 11 in first here, 4895 times 11 minus 1.9752, close it, plus 55.2877. So when I put 11 in, we get 48.59796.025 out. Now, got to go back, change the 11 to 8, and I get 78.866222498. Now, I'll put, say, this one first, minus that one. Since I put 48 first, I'll put 11 first on top. So 48.59796.025 minus second answer. That'll pull that 78 back. Oops. What? Oops. I don't know how that happened. I apologize. Oh, that was the 0. Let's try that again. There we go. Divide that by negative 3, or excuse me, just 3. 11 minus 8. The nearest tenth, 0.1, negative 10.1. Explain its meaning in the given context. Each month, the average monthly high temperature decreases by 10.1 degrees. Point M, T, comma, 4/7 is located in the second quadrant and it's on the unit circle. All right, we're on the unit circle. That means cosine and sine. Determine the exact value of t. Well, t is cosine, so we're just looking for cosine. I don't remember if it was sine or cosine first, the way we did it. It works either way. I apologize if we always did sine squared plus cosine squared. This is the same thing. So I got t squared plus 4/7 squared equals 1. Remember, you just square the 4, square the 7, or you could type it in, 16/49. Then we'll subtract the fraction 1 minus alpha y equals choice 1, 16/49. We get 33/49. Take the square root. Now, I don't know that one. I'll leave it as radical 33. Hey, that can't be reduced. Cool. Over 7. But we are in the second quadrant here, which is left and up. So our cosine should be negative. On the grid below, graph. Okay, hey, this shouldn't be too bad. We just got to remember math, log base, space 2, x minus 3, hit over to get out, plus 1. Maybe hit graph just to take a little gander here. In second table, error. 4, 1, 5, 2, 7 is 3. 11, so 6, 7, 8, 9, 10, 11 is 4. And I think that's enough. So remember, you have an asymptote right here where it kind of disappears on the graphing calculator. Then, even though it goes real slow, you're still going up. There we go. An asymptote, you didn't have to answer this. Just to remind ourselves, a vertical line right here, that would be x equals 3 is the asymptote. Didn't ask that, didn't need to do it. Moving right along. All right, now the first thing, and remember, if you really want to, if you remember how to, which I think everyone does probably, type this in to your matrix, RREF. Maybe get the answer ahead of time. That way you know you're doing it right. But whether you do that or not, look, they're sneaky here. They stuck that A over there. We want it lined up. So I'm going to minus A plus 6B plus 2C equals 14. Now I'm just going to kind of get rid of that right there just to make sure I don't accidentally use it somehow. I'm not going to use A, B, and C. I'll just go with 1, 2, and 3 here. Now, even though we had to move this A over, this one's actually not too bad because we have A's and then a negative A. So that'll just right off, cancel right out, nice and easy. We'll do 1 plus 3. A plus negative A cancels, 4 plus 6, 10B. 6 plus 2, 8C. 23 plus 14, 37. Now we have to use 2 since I didn't use it before. And let's just add that to 3 so it'll go nice and smoothly. 2 plus 6, 8B. C plus 2C is 3C. 2 plus 14, 16. Well, all right. 10B plus 8C equals 37. 8B plus 3C equals 16. Either equation, or excuse me, either variable we pick here to cancel out, we're going to get, we have to multiply both. So it doesn't really matter which one you pick. The B's just pop out in my brain. I'll turn them into 40s. One of them's got to be negative, so something will cancel. If you just multiplied them by each other and did 80, that would be fine. It works as long as you get, as long as you do it right, as long as you get the same number here. So we got negative 40B minus 32C. And then we got 37 times negative 4, negative 148. Now on the bottom, 40B plus 15C equals 80. B's cancel out, negative 17C equals negative 68. Divide 4. I'll use this one. Numbers are a little bit smaller. It doesn't really matter though. So 8B plus 4 times 3 is 12. 8B equals 4. So B is a half or 0.5. Now, we'll go up to one of the originals. Hey, this one's nice and easy. A plus 2 times 0.5 plus 4 equals 2. A half of 2 is 1. 1 plus 4 is 5. Subtract 5, negative 3. Oh, geez. Determine A over B. That just means divide, quotient, remainder. So we got x plus 2. Now, there was a little bit of sneakiness in this one. X to the fourth plus 2x cubed. Oh, there's 0x squared, so I need to put that in as a placeholder. So I multiply by x cubed. So 0, bring down that 0. So I need 0x squareds. 0, bring down the 4x. So I need 0x's. This one's kind of a weird one here. 0x's, 0 times that whole thing. And again, the reason why I put a 0 here, I can't fit this whole binomial into just this monomial. 4 minus 0, bring this down. And then we'll multiply by 4. Negative 10 minus 8, negative 18. So this one's a little bit of a weird one. Again, the reason that this all happened, right here, when we subtracted, we get 0. The next number is 0. So clearly I can't fit this into nothing. So times by 0, subtract, you get 0 still. We're just doing this to maintain our proper place. Bring the 4 down. You can't fit a binomial into just an x. So we put the 0, multiply by 0, you get 0, subtract. Hey, now we can fit it in. There we go. No, it's not a factor. The remainder is not 0. A radio station claims to its advertisers that the mean number of minutes commuters listen to the radio station is 30. The station conducted a survey of 500 of their listeners who commute. The sample statistics are shown below. So, of course, simulation was run 1,000 times based upon the results of the survey. The results of simulation appeared below. Based on the simulation results, is the claim that commuters listen to the station on average 30 minutes plausible? Explain your response, including an interval containing the middle of 95%. Oh, here we go. And there's 100. Be careful of that. So we got to go the mean plus and minus 2 times 0.934. I'll do the minus first this time. Minus 2 times 0.934. Round to nearest 100th. And then I'll go back and I'll change my minus to a plus. Sorry, guys. I don't know how. Change that to a 29. All this will do will just add 1 to both of these. I apologize. There we go. All right. I just realized that I wrote 8 there when it says 9 right there. Sorry about that. All right. Is it plausible? So this is the middle 95%. Yes, 30 is between 27.23 and 30.97. Anything in that 95% is considered normal. And again, sorry for that bonehead writing 28 when it clearly says 29. Okay, all right. So we add the 2x. This one's a little different. Got to divide by 3. So if I square both sides here, this one, don't make it harder than it has to be. Just square the 3, you get 9. Do this off to the side again. 4x squared minus 10x minus 10x plus 25. So that gives you 4x squared minus 20x plus 25 equals x over here. Now, you could do this a couple different ways. Maybe just think multiply by 9, or if you do this is rational, get a common denominator, and hey, we'll drop it. Minus 9x. Now, at this point, if you don't want to bother with AC factoring, because there's no GCF, just break out the quadratic formula. It's right there. You're going to get numbers for it. So you can just type the whole thing in. To me, since I just looked at this and thought, hey, 4 times 25 is 100, and conveniently, 4 plus 25 is also 29. They just both have to be negative. I like it when that happens and you don't really have to think about the factors. So again, if you just wanted to use the quadratic formula there, that's fine. It just happened to be that A and C worked out to be the factors we need. So that was nice and easy. GCF 4x, x minus 1. Subtract out the 25 here. Oops. So we get 1. And ooh, this is weird. Since there's a number here, I have to make the equation. Now you can leave it as 25 over 4. Grab your calculator if you want, though. Hey, that's not a bad decimal. And since I have to check my solutions, well, we just stick with this. Easier to type in, by a little bit at least. All right, so now we got to check. Square root of 1 is 1 times 3. 3 minus 2 is 1. Are those equal? Nope. So reject. Now we'll plug the negative 5, or excuse me, the 6.25 in. You do get -5, so that one's good. Again, don't circle it. Just write reject on that one. I'm just demonstrating. Oh, wow. Sorry, I've been cutting a lot of that off. I'll leave that up there for a little while. I'll walk you through this too. Sorry, I didn't realize I'd been cutting the bottom of that off. So AC factoring here, like I said, 4 times 25, 100. And 4 plus 25 is 29. Easy to find the factors. Factor that out. Go through that whole process. No number on that factor. You can just write 1. For this one, you got to write the equation out. The checks, the 1 doesn't work. 6.25 does. Tony is evaluating his retirement savings. He currently has $318,000. Ooh, I don't like that. A big number like that with a graph. All right, in his account, which earns an interest rate of 7% compounded annually. All right, annually. That's just normal. Once a year, that's just the basic formula. It's only going to be like the compounding formula when it's like 7% interest for the year compounded monthly or something like that. He wants to determine how much he will have in the account in the future if he makes no additional contributions to the account. So again, they say this here trying to make you do more work, but if it's annually, that's just once a year. That's just normal, the normal formula. Hopefully we're making money, or else Tony is not going to be happy when he graphs here. 318,000, 1.07 T power. Oh boy, why do they have to do this to us? We have to go all the way from 0 to 20. Let's see, 1, 2, 3. You don't have to do this since we're going by ones. I just want to make this easier on myself to graph. And yep, you got to use every box. Now, let's just take a look at the numbers we're going to get here. Oh, battery's dying. All right, let's try this again. Let's just take a look at the kind of numbers we're going to get here. Although I think we already have a good idea that this isn't going to be the most fun graph ever. However, all we got to do is try to plot these points. This wouldn't be too bad. Okay. All right, let's see. We got to go all the way to 20. Okay, so we're getting in to scientific notation. Let's just look and see how high this is. 1.23. Now this says E. That's scientific notation. 10 to the 6th power. That means we got to make a big number. So I'm going to move the decimal to the right. 1, 2, 3, 4, 5, 6. We got to go all the way up to 1,230,000 or so. You get to choose on this. Let's take a look. At 1, we know it's about at 300. At 1, it's about 340,000. So if we got to go from 300,000 or so all the way up to 1,000,000, let's just go by 100,000s. Maybe you could do this every other block. They're not messing around with this one, though. We'll have to do some good old estimating of how far up or down into the block to go. All right. And at 20, this is at 20. So I don't need anything higher than this. All right. Let the good times roll here. 0, 318. So that's going to be a bit below. And then below half, below halfway. Then that 1, it goes up just a little bit. Now just be careful when you go through. 2 goes up just a little bit more. 3's getting up there to the 400,000. 4, it's a little bit above. 5, it's almost halfway to 500,000. 6, it's a little bit above half. 7, you just hair over. 8, almost halfway. 9, pretty close to 600. 10, a little bit over 600,000. 11, a bit over half. 12, 71, so you're a little bit over. Well, 716, excuse me. 13, a little bit over. 14, now we're up into the 800s, just a little bit over. So at 15, we're almost to 900. 16, we're already almost halfway. Almost there. Hey, there it is, 1,000,000. 1e to the 6th. 1 times 10 to the 6th. So that's a 1 with 6 zeros after it. So that's just a little bit above 1,000,000. Again, that would be 1,070,000. So that's 1,150,000 at 19. And then at 20, 1,200,000 something. Do not connect the dots. This is an exponential graph. I'm going to try to, my hands are so sticky here. I'll try to get this from the weather. Try to get this. Don't do a zigzag. Don't connect the dots. Try to draw nice little curve. Then you can always go back and use my trick. Make your dots a little bit bigger. There. That's tedious. That's annoying. And you got to remember what scientific notation is, but this was mostly just reading values off of the graphing calculator. To me, that's not too bad. Tony's goal is to save 1,000,000. Determine algebraically to the nearest year how many years it will take him to achieve his goal. So we're just going to put this as 1,000,000. 318,000. 1.07 to the t power. Now, if you have to solve any exponential equations here on this regents by taking a log, please We've done so many of these. Don't forget the steps. Divide by 318,000. All you can have are the base and the exponent. 1 million divided by 318,000. Hate having to write the decimals out, but take the log of both sides. Divide by the log of 1.07. Now watch. I have to type this out again. Log, second answer. Take that last answer. Close it. Divide by log 1.07. What's it say? To the nearest year? 17 years. Explain how your graph confirms the answer. All right, let's take a look. It hit 1 million at 17 years. There we go. Oh, geez, they output. Yeah, sorry. The output on my graph at t equals 17 is 1 million. That would be how it confirms it. Because it says 1 million at t equals 17. All right, now one little bonus question here. I realized a little while ago that had been a while since we had done anything like this. So this has nothing to do with the regions. This is just a little bonus question. We haven't reviewed this. This is another exponential, but I don't have to use logarithms here. You'll probably remember after I start doing this, because I can drop this 25 down. 25 is 5 squared. And then power to a power multiply. Now, if these are equal and the bases are equal, they're both 5, then the exponents must be equal. Now just solve for x, subtract x, divide by 7, 3/7. I mean, they can do one like this. They could do one. Now be careful on this one. Be careful. 8 is not 4 squared. 4 times 4 is 16. 4 times 2 is 8. Squaring would mean 4 times 4. So I have to drop both of these down to 2. 2 squared and this will be 2 to the third. Now also, I can't have a 2 up here and a 2 down there. Remember, if I flip this over, I just have to make the exponent negative. Negative exponent means reciprocal. If we work backwards, if I have a -3 exponent, I send this 2 to the denominator. There's nothing else up here, so I stick a 1 there. Going forward, if I want to move this 2 upstairs, change the sign back to negative. Now it's a common base, power to power multiply. So in this case, distribute 2x minus 6. These are equal and the bases are equal. The exponents must be equal. Add 6. 1.5.
All right.